So welcome back to Math Addict 59 YouTube channel. First video in a while. So here's a situation involving the half-life and how to analyze the half-life. Now in class, we brought up this. Hang on a minute. We brought up this formula. I'm gonna write it best I can because I no longer have a touch screen. I'm gonna have to go home and get myself a new touch screen. So this is not gonna look very pretty. Make sure you realize that H is the half-life and it's a constant. Yep, that was very slow. Make sure you realize that AO is initial dose. Yeah, like I said, I'm having to write this with a mouse and I'm already getting carpal tunnel from this. So T would be the time that after you took it. And A of T would be amount left. Or yeah, part of the dose left. Like I said, not the prettiest writing. Maybe I should be typing this, not writing it. But let's just say hypothetically that it was a 40 milligram dose. And the information about half hours is given. Now you could just get away with convenient values. And you might not even need to use the T-chart. Like when everything starts, it's your initial dose. Now what this means is every time 0.85 hours or 51 minutes passes, the concentration of drug decreases by half. Or should I say, you get half of what you originally. Now, what you hopefully will realize without too much of this formula is that 0.85 hours later is 1.7 hours. And then the graph, or should I say, the concentration loses another half. If you keep this process going, I think it's 255 actually. You're down to 5 milligrams and maybe the relief starts to wane off a little bit. But this is typically a drug that you might only take once a day. So not sure how that all works. Now at the 3.4 mark at the fourth half-life, the drug is often deemed to be out of your body and it's time for another dose. Now, the way the graph would look, if you're doing a graph of this, you're going to put your dosages as the y-axis. Now, I'm not necessarily going to include all values of 10, but I'm going to include the ones that matter. And then you need to evenly space out the length of the half-life. Now, if this were like a 5-hour half-life, you would put 5, 10, 15, 20. But these are this is data driven, and this is what the hours we chose will result. So the graph would always start at the y-intercept, which is the origin, not the origin, which is 0.40. And then the graph will show that the concentration is goes down by half every 0.85 hours. Now, people ask me, does it ever truly run out? No, it doesn't. But the amounts become minute to where you probably need another dose. Anyway, we'll see how that helps, and make sure you tune in for any future videos. Thank you.